to, but next week, just so you know, it's Tuesday, Thursday. Okay? Tuesday, Thursday next week. Okay, so we are gonna finish up what I was teaching yesterday in section 8.2 today, and then we're gonna start 8-3. And we're gonna go all the way down here to these rules. These rules are on your cheat sheet that you have, so you don't have to memorize them. But what's gonna happen in this part is they're gonna give you 3 sides of a triangle. And they're gonna ask you, is this, or could these 3 sides form a triangle? That's the first question. And the second question is, if it can be a triangle, is it right, acute, or obtuse? Okay? So first, let me explain how you can tell if 3 sides make a triangle. Did you guys ever do an activity in an early, like elementary class where you use straws or something that sticks together, or you can make stick together, where you tried to make triangles given 3 different sizes? Have you ever done that? Okay, so here's the deal. When you have 3 sides and you're determining, can I make a triangle out of that? Let's say if I said we have one side that is, hold on one second. One side that is 2, one side that is 3, and one side that is 6. Okay, let's say that I did that. If you went to, say that I measured a 6-inch straw, and then we did the 2-inch straw here and the 3-inch straw here. Oh, that doesn't look very accurate, but pretend that one's a little bit bigger. Do you feel that you would be able to make a triangle with those lengths? If this is 6, and this is 2, and this is 3, and you tried to move those, would they touch, or would they fold back down onto this side? They would fold down, but they wouldn't touch actually. So if this is 6, this is 2, and this is 3, what would happen is your 2 would fold down here, your 3 would fold down there. They would not touch, okay? Then, let's say that I changed that and I said, okay, this time, what if this was 4? And then I went over here and changed this to 4, okay? What would happen this time if I made this 4? Okay, when I go to fold those down, this one would fold down, and they would touch when I got right here. They would fold right back down, and it would look just like a straight line, okay? So what do you think the rule has to be for 3 sides to make a triangle? Does anyone see it? They have to add up more than 6. Very good. So here's the rule that you have. The 2 smaller sides of a triangle, when you add them together, has to be bigger than the 3rd side. It can't be equal to, it has to be bigger than. And 2 plus 4 is not greater than 6, so you can't form a triangle. If you had 2, 5, and 6, then it would work. Does that make sense? Okay. Now, the second thing that we need to learn today is, how do we tell if those 3 sides, once you're given a triangle, how do we tell if it's right, acute, or obtuse? Okay. So 2, 4, and 6 didn't work, but let's say now I gave you 2, 5, and 6. Okay, first thing you're always going to want to check is 2 plus 5 greater than 6, and it is, so yes, they do form a triangle. If they form a triangle, then what you're going to do is you're going to put c squared on the left, and you're going to put a squared plus b squared on the right. And it's super important that you put c squared here, and then a squared plus b squared, okay? So how do you know which one's your c? The biggest one, very good. So what I'm gonna do there is I'm gonna put 6 here. A and B are your two smaller ones in any order, so I'm gonna go 2 squared plus 5 squared. 6 squared is 36, 2 squared is 4, plus 5 squared is 25, so this is 29. Now, what you have to do is determine what sign goes in between those two. Do you guys agree 36 is greater than 29? So what you're gonna do is go to your cheat sheet. If the sign is equals, it's a right triangle. If your sign is less than, it's an acute triangle. And if it's greater than, it's obtuse. If you had these two switched around, you would get everyone wrong for the acute and the obtuse triangles. C squared has to go on the left. So we had greater than, and because we have greater than, that makes it an obtuse triangle. So our answers for this one would be yes, it made a triangle. And because it made a triangle, that means you keep going with the problem. If it didn't make a triangle, you'd stop there and say no. So let's try this. Let's go down here, okay? First question you always think is the two smaller sides greater than the third side, okay? Is 49 greater than 41? Is it? Yes. When it's a yes, that means we're going to keep going with the problem, okay? So now I'm going to put c squared and a squared plus b squared, and I want to find what goes in between there. C is always my biggest side, okay? So c is 41 squared, a squared is 9 squared, and b is 40 squared, okay? Now, 41 squared is 1681, and 9 squared plus 40 squared is also 1681. So obviously those are equal, okay? And I think I have, so I have to go back here. And if they're equal, that means that it's a right triangle. So that's kind of what we did yesterday. A squared plus b squared equals c squared. So this is right. If you don't have a triangle, you get to stop right there. You don't have to keep going with that, okay? Now in this one, we're gonna check, is 10 plus 11 greater than 13? Is it? Is 10 plus 11 greater than 13? It is. So yes, we have a triangle, okay? Then if I try c squared and a squared plus b squared, c is my biggest, which is 13 squared, and then this would be 10 squared plus 11 squared, okay? Now, if I checked, 13 squared is actually 169. This would be 100 plus 121, so it'd actually be 221. And what sign goes in between there? It would be less than, right? So if it's less than, what kind of triangle do we have? Acute. So equals means it's right, less than means acute, greater than means obtuse. So here I could go, is 7 plus 8 greater than 14? And it is. Okay. Then what I need to do is my c squared and my a squared plus b squared. C is your biggest number, which is 14 squared. A is 7 squared, B is 8 squared, or vice versa there. Now, 14 squared is 196. 7 squared is 49. 8 squared is 64. So that would be 113. So here we have greater than. And if we have greater than, what kind is it? Obtuse. Okay. All right, now we have some decimals, but that's okay. So again, we're gonna check, is 6.2 plus 13.8 greater than 20? Is it? No. Isn't this 20? And 20 is not greater than 20. And you're gonna like those, because then all you have to do is write no, and then you're done with that problem. Okay? And then we have one last one. Now, one of the things you have to do is check which side is your largest one, okay? When you do that, what you can do is like take the square root of 8 on your calculator and just kind of get an estimate of it. You can't use that number going forward in the problem, but if you took square root of 8, it's approximately 2.83, so I'm gonna just write that above it, okay? Then I'm gonna take the square root of 14, whoops. Square root of, was it 13 or 12? Sorry. 3.46, okay. So once I do those just like approximations like that, then what I can do is check, is, I know this is my biggest one, 2, 2.83, and 3.46, so I can check, is 2 plus square root of 8 greater than the square root of 12? And think about it, this is approximately 2.83, approximately 3.46. Wouldn't this be 4.83 approximately, which would end up being bigger than 3.46? So that is yes. Okay. Now we're gonna go down and we're gonna do our c squared and our, oops, I don't wanna put a sign there though. And our a squared plus b squared. Okay, now c, you can't, when you get to this part, this is important, you can't use these estimated values, because if it was a right triangle, you wouldn't see it. So when you get to the part that you're putting them in here, you have to use the actual number. So for c here, what we would have is the square root of 12, and we're squaring it. Can't use the 3.46, have to use the square root of 12. A is 2 squared, and B is root 8 squared. Now, do you guys know in math what happens if you square a square root? They cancel, right? So wouldn't it just be 12, right? And then 2 squared is 4, and root 8 squared would be 8. So isn't it equal? And what kind would it be? Right. So your answers for these would be yes or no here. If it's yes, then this answer would have to be acute, obtuse, right. Do you guys want to, so I'm doing 2 pages of the next one. That one's easier. But do you guys want to copy this down super quick? So it's this page number with those 7 questions. Okay. Did I give you enough time? All right. So now you're going to look at the new packet. This is easier than what I just showed you. Okay. So in geometry, there are 2 special right triangles. We're going to learn one today and one tomorrow. So the first special right triangle, I'm going to go down to the bottom. This right here is on your cheat sheet, so you don't have to remember this. But when you have a special right triangle, one of the kinds is if you have a 45, 45, 90 triangle, okay? Do you guys remember learning isosceles triangles, that if these 2 angles were equal, do you remember how those 2 sides would be equal? Okay, so when you look at this, what we're going to label our sides across from the right angle is going to be the hypotenuse, and we're just going to use an H. And then these 2 in a 45, 45, 90, they call them L's for legs, okay? The reason they're both the same is that these 2 sides are congruent, okay? Now, here's what they're going to do today. They tell you that the relationship for this triangle is that you take your L times the square root of 2. That is a formula, and like I said, this is on your cheat sheet, so you don't have to memorize that, okay? Across from the right angle is your H. If these 2 sides are congruent, that makes these 2, or I'm sorry, if the 2 angles are congruent, those sides are congruent. So what's going to happen on this next page is they're going to give us the H or the L, and whatever one they give you, you're going to use this formula to find the other one. So let's go to this page right here, okay? Now, first thing I would always do, if that's 45, this is 45, we know our angles are equal. You don't have to mark all of this, but if this is 45, then those 2 sides are equal, okay? Another thing I would mark here is these would be your legs and this would be your hypotenuse, okay? Now I'm going to go to my formula, and in this one, what we're looking for is our hypotenuse, so that's x. Our leg is 9, so it's 9 times the square root of 2, okay? So I'm going to teach you another thing today about radicals. There is a rule, or a couple rules with radicals we have to learn, and if you have a square root just like in a normal expression, think of it as kind of being on top of a fraction if you had a fraction, you can leave that exactly how it looks, okay? If you don't want to leave it like that today, you certainly could go to your calculator and you could go 9 times the square root of 2, and get 12.73, and that would be absolutely fine too. So either of those would work. Okay. Now let's look at this one. So we have a 90-degree here, 45 and 45. Okay. So again, the angles would be equal. That makes these two sides equal. These are your legs, and that's your hypotenuse. Everybody understand that part? Okay. Now, in this problem, we're given our hypotenuse is 88. L is our x, and that's times square root of 2. So here what I have to do is solve for that x. So what I'm going to do to get rid of that square root of 2 is I'm going to divide by square root of 2. These are gone, and my answer is 88 divided by square root of 2, which you could punch into your calculator, but I'm also going to show it to you a different way. So next year when you guys take Advanced Algebra 2, this is another thing that you guys are going to be doing, and it's called rationalizing the denominator. There is a rule in math that you cannot leave a square root on the bottom. And how you get rid of that square root is you multiply it by itself. Okay? So to get rid of a square root of 2 on the bottom, you multiply it by itself. And then what happens, on top, you have 88 times the square root of 2. On the bottom, what would we have there? 2. The square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay? Now, if you do it this way, what you have to do then is see, is this simplified? You can't change anything under that square root. That stays as square root of 2. But you can simplify this fraction if you can, okay? 88 divided by 2, isn't that 44? So I could write this as 44 times the square root of 2. So 88 divided by 2 is 44. That's how I can write that. Now, let's say we went back and you're like, I'll worry about simplifying that when I get to Algebra 2 next year. What you could do instead is just divide that on your calculator and get it as a decimal. So what we would do is we would go 88 divided by 88 divided by square root of 2, and that's 62.23. So that is 62.23. And I am fine with you guys doing it either way. Okay? Now if we look at C, again, if that's 45, this is 45. These are each L's, and this is my hypotenuse, okay? So if I go to my formula, my H I know to be 3 root 2. L is what I'm looking for, that's X, okay? Now I'm solving for X. Do you guys get that I would divide by the square root of 2? So these are gone, okay? And then on the other side, would these be gone too? Yeah. So X would be 3. Okay. All right, now let's look here. Again, 45, 45. So these are my L's. This is my H. And in this one, I know the L. So H would be X. And then I have 5 root 2 is my L. And notice I have to multiply that by root 2. What is root 2 times root 2? 2. So do you guys get this is 5 times 2, which would be 10. If you put that in your calculator, you have to be careful. I would probably, if I was putting that in my calculator, I would hit enter here before I multiply by that root 2. Otherwise, you have to be careful of parentheses. Okay, so here's your second assignment right here. And you can do them both on the same page, or on the same page and get that turned in. Did you think it was hard today? Just a reminder about the calculator. Try to get a graphing calculator by Friday. I will try to remember to bring a couple over, but it's better for you to have your own.